Hey everybody, this is the first of a couple of really quick podcasts just to help kind of supplement what we're doing in class so that you can see it a little bit more clearly, so that rather than having to delve way too deep into examples next time around, we can just move as quickly as possible to the hands-on type activities. When it comes to an array, what we first have to really understand about arrays are when we read data into them, they are fully and completely unsorted. So what that means is part of the data someplace will have been sorted by an account number, potentially by a timestamp someplace, so like transactions in a register someplace. But they're not necessarily sorted when we want to look at the data when it's populated into an array. So one of the first responsibilities we have as developers is to make sure that the data we have is sorted in a way that makes sense. Now, I want to focus on the sorting aspect of this in a separate podcast. That one is the bubble sort. It's a brute force method that works painfully elegantly well. And we're going to have a chance to walk through that. But here I just want to focus initially on the searching of those arrays. So let's say, for example, we have populated an array with data. So what kind of data? So if we look at things like our grades data, so if you just think about things like a classroom, we'll have 24 students in a classroom. Of those 24 students, each student has a grade average. Now, if I simply go from left to right, from front to back, through that classroom, I'm not going to get data that's in any way, shape, or form sorted, right? So if I start at computer 01, the student's going to have a grade average 90. Go to 02, that student's going to have a grade average 54. If I go to student 3, that student's going to have a grade average 85, and so on. So it's good that I have data there. It's in an array. I can do some operations there. So let's suppose I have that data read into my array, and now what I want to do is to get a certain number out of that data. So I am looking for students who have scored, or students whose average rather, is 50% or less. So the number I'm looking for there is 50. The easiest way to be able to go through and do this is to do a linear search. What a linear search essentially does is say, start at element number 0 and look at the value stored into that element, and compare the value stored in that element to the value you're looking for, and then keep proceeding until you have run out of elements in your array. So what does that essentially look like? In code, I can point you to page 95, linear search of an array, and we can just walk through that a little bit. Ordinarily, what I would try to do is plug a little bit of a screenshot in here for you, but I'm recording this on my iPad, guys, and my hands are a little bit tied. So I know you can read, so I guess I'm not going to slow down too much for that. So again, this is in the middle of page 95. What essentially we have to do with our first line is provide a required value to how long our array is. So what this is presuming is that we know how long our array is. If we look at something like the classroom example, I know I have 24 machines in there. So the required value for that would be 24. However, most of the time you're not going to know how many values you have read into that array, because it's going to come from an external data source, probably out there. Really, in that case, what we would use is that end of file marker to help control our loop, that EOF. And in so doing, we do not have to know exactly how many elements are in our array, that will take care of itself for us. Line number 2, set element underscore found to false. What essentially element found is a Boolean. So when we find the number we're looking for, boom, switch that to true, and I'll be able to get out of my loop. Set index to 1. So what that's saying is we are moving from element number 1 in our array, which again, in the runtime languages is not particularly standard. Here in the text, it's not even the standard they use all the time. So it's just something to be aware of. Array operations usually do start at 0, but again, when you look at modern computers, when we look at modern data storage, for the most part, we have such a tremendous amount of computational overhead that it is in no way, shape, or form detrimental to throw away essentially the 0th element of our array. So if you're setting the index to 1, make sure you're always setting the index to 1. If you're setting the index to 0, make sure you're always setting the index to 0, and that way you avoid the off by 1 issue. The big magic, the heavy lifting here is done in our do-while loop. You'll notice that we're looking for 2 things here. This do-while loop, is going to continue as long as, and this is the first set of parentheses, not element found. So as long as element found is still equal to false, it's going to continue iterating, so going from element to element to element in our array. So we have 2 conditions here. As long as index is less than or equal to the max number of elements. What essentially that's doing is giving us a secondary control. If we're looking for the number 50, what happens if it's not in that array? Well, we need to be able to give our loop a means of escaping that loop. If we're simply looking for not element found and the number 50 is never ever in that array, this loop is going to continue forever. So that's a situation we want to avoid. So the AND statement here is absolutely necessary because that's going to help us avoid an infinite loop. Now, inside of our loop, the very first line there, if array at index. You'll notice in on the line immediately previous to our do while loop, we set that index to 1. So what we're saying is, if you look at in our typical example, we've got the student grade array. If we look at student grade array at index 1, so that essentially refers to the first student. If that value in there is equal to input value, so that's what we're reading in from the array, we know that element found is true. So what we're saying is if the first student's score is 50, yes, we have found the student who scored a 50 on a particular test or whose grade average is a 50. So then we're setting that element to true. Else, because we haven't found it, so the first student score in there instead of 50 is 70. That means we have to continue to iterate, so to go from element to element to element in our array. So we do need the else statement there. Index plus equals 1, because what we need to be able to do is come back through our array, look at the second element next time around, and continue to do those comparisons. So really, those, 5 lines essentially of code inside of that do while loop can accommodate an array of any size. If there's 24 students, if there's 5,800 students, if we're looking for a much larger sample set to return a piece of data to us, that do while loop can accommodate an array of any size. And that's really what makes arrays fantastic. We don't have to do a lot of logical operations to be able to traverse an entirely large set of data. So that's fantastic. You'll notice outside of our do while loop, we have a consideration here. If element found to be true, you'll notice that there's still a little bit of cautious optimism there. What that line is essentially saying is, look, I know you've gotten out of that array. There's two ways to get out of looping through that array. One is you found the student with the average of 50, or you didn't find the student with the average of 50 and you happen to hit the end of your array. So we're not printing the array at index if we didn't find the student, only if we have found that particular one. Then the else portion of that is to print out value not found. That is a good user-facing design consideration there, because without that, the only time this particular pseudocode example prints anything is if the student with the average of 50 is found. That's not necessarily going to happen. So without the third to the last line there in that code sample, what essentially happens is you run your piece of code. It goes through an array of size 20, of size 24, of size 5800 or whatever, and it doesn't find anybody. And it stops. But the user is left with a pretty big question, right? You've never displayed anything to the user. You've never told them we found a student. You've never told them we didn't find a student. Having that display output there on the third to the last line is absolutely required, essentially, right? Because we don't go back and tell the user that, hey, wait a second. Look, we've actually successfully completed the operation, and good news, nobody had a 50. That doesn't necessarily mean that nobody had lower than a 50, but it means that nobody had exactly a 50. So you do need to keep in the fore of your mind here, what is it that the user is going to expect in the way of an output to assure that this is actually going through and completing in the way that they expect it to. So that is a linear search of an array, a brute force, element for element traversal of an array of however big the size is. That simply goes and checks your search criteria, 50, against every element in that array. Inelegant? Maybe, but effective? Absolutely.